Right, so here's a video on quadratic equations. Now I know you would have met this on the GCSE specification, but it is absolutely fundamental to a lot of the A-level stuff as well, so I thought I would go over some of it. So the general quadratic equation can be written as ax squared plus bx plus c equals 0, where a, b and c are real numbers, so any numbers that you know at this stage, but such that a doesn't equal 0, because if a was 0, it wouldn't be quadratic. Okay, so there are three kind of main ways to solve a quadratic equation. So we can factorise. We could use the quadratic formula. We could complete the square. Or we could use a graphical approach to solve or estimate solutions of a quadratic equation. Today we're going to be focusing on factorising and the quadratic formula, and I will use the completing the square method to derive the quadratic formula, but won't actually solve any quadratic equations using completing the square. Okay, so the idea of factorisation then is to take this quadratic equation and somehow write it as the product of two brackets. So if a is 1, then we're going to end up with an x plus something and an x plus something else equals 0. If a isn't 1, then we could take a out or divide the whole thing by a. Or we may have a situation where there will be an a inside one of the brackets, like this. Or we may even have two different numbers altogether. Let's call it A1 and A2, such that the product of these two numbers, A1 and A2, equals A, so that the coefficient of x squared is still A. So the idea is to get it from this form into perhaps one of these forms. And once it's in one of these forms, it's called factorised form, we can very easily read off the solutions to the quadratic equation, because solutions are either when this bracket is 0 or when this bracket is 0. So when this bracket is 0, x is minus alpha. When this bracket is 0, x is minus beta. When this bracket is 0, x is minus alpha on A. When this bracket is 0, x is minus beta. When this bracket is 0, x is minus alpha on A1. Or when this bracket is 0, x is minus beta on A2. So these are just some algebraic examples of how we can read off from factorised form the roots of the quadratic. It's whatever value of x makes one of the brackets 0. Okay, so let's have a look at some examples then. So here we have a fairly straightforward one. Coefficient of x squared is 1, so if it does factorise, it's going to be x at the beginning of each bracket. And we're looking for two numbers that multiply together to give 6, but add together to give 5. And I know that that just happens to be 3 and 2. So now that I've factorised it, I can then state the solutions are minus 3 and minus 2. So those are the two solutions to the quadratic equation. And we can take those two solutions and run it through to make sure it works. Okay, minus 3 squared is positive 9. Positive 9 minus 15, because x is minus 3, is minus 6. Add the 6, it does equal 0, so it is indeed a solution to the quadratic equation. Here we've got, again, the product of two brackets equals 0. This time we've got a 2 at the beginning, so it's either going to be a 2x and an x. And we've got a 3 here at the end, so it's got to be a 3 and a 1 if it does factorise, and I just happen to know that it's going to be plus 3 in there and a minus 1 in there. A little bit of trial and error, and we can then read off the solutions as either x is a half from this bracket or x is minus 3 from this bracket. And those are the two solutions to that quadratic equation. If you do struggle to factorise, there are plenty of videos out there on YouTube that will give you some more detail in some methods on how to factorise, but I tend to just do a bit of trial and error in my head to get to the solution, or use the quadratic formula. So 20 now on the end. This is lots of factors, so it could be a 4 and a 5. It could be a 2 and a 10, it could be a 1 and a 20. Those can swap round because these brackets aren't symmetrical. One of those will be negative, one of those will be positive. So there's lots of combinations to try here. But it just so happens that, I know the solution to this. It's plus 5 there and minus 4 there. We could check that. Times those together, we get minus 20. We get a plus 5x minus a 12x. Okay, 5 times x is plus 5x, minus 4 times 3x is minus 12x, and that gives us minus 7x, so that works. And of course we have the 3x times the x, which is the 3x squared. And again, we can read off the solutions to this. X is going to be minus 5/3 from the first bracket, or x is going to be positive 4 from the second bracket. And again, you could run those two values through the original quadratic equation to confirm they are indeed solutions. And my final example here, x squared minus 2x minus 19. If this were to factorise, it would factorise in this form, because the coefficient of x squared is 1. I'm looking for two numbers that times together to give minus 19. So it's either 19 and 1, minus 1, or it's minus 19 and 1. I don't need to swap them around in this case because they're both x. So the symmetry of the brackets saves a little bit of work. The problem is here is neither of these combinations actually give me a minus 2x. So this is an example of a quadratic equation which doesn't factorise. And that's one of the main problems with the factorisation method, is it's not always going to work. This is why I prefer the quadratic formula, because that will always work. Or if there are no solutions, it tells you straight away. So, the quadratic formula then, the derivation of it. Now, I'm sure you all met the quadratic formula. It is on the GCSE specification. And a quadratic formula applies to equations of the form ax squared plus bx plus c equals 0. And I'm just going to derive it for you. You don't need to know the derivation for the A-level course, but I think it's good to see where it's come from. So first of all, I'm going to take this equation, I'm going to divide it by a, which we've already established is not 0, otherwise it wouldn't be quadratic. Okay, so that divided by a, the a disappears, b on a and c on a. I'm now going to complete the square on this. So to complete the square, I put x plus half the coefficient of x. So it's b on 2a, and I'll square that. So when I multiply out this bracket, I'll get the x squared, and I'll get the b on ax. Unfortunately, I'll also get a b squared on 4a squared, which I don't want, so I need to subtract the b squared on 4a squared. And I've still got the plus c on a over there kicking around. So this portion here is identical to the first two terms here. But the advantage of this line is that x only appears once as opposed to twice. So I can now make x the subject. So bring those two across, I'll get x plus b on 2a all squared is going to be equal to b squared on 4a squared. Subtract c on a, which I'm now going to write as b squared minus 4ac divided by 4a squared. So I've taken this fraction and times it top and bottom by 4a, sorry, so that the denominator of both these fractions are the same. So I can then combine the two fractions together. Okay, and we can see that the b squared minus 4ac term, which is in the quadratic formula, has appeared. All right, now we square root to get rid of the squared. Of course, when we square root in algebra, we must consider the positive and the negative situation. So it's going to equal plus or minus the square root of b squared minus 4ac. And because the bottom is already a nice square number, I can already take it outside of the square root sign and leave it as a 2a. And now I just need to subtract this across. So you end up with x equals minus b on 2a plus or minus the square root of b squared minus 4ac divided by 2a. And now I can combine the two fractions. The denominators are already the same. So we end up with that famous quadratic equation. X equals minus b plus or minus the square root of b squared minus 4ac. And that is all divided by 2a. And that is true as long as a doesn't equal 0. And also, little caveat to this, this is true if b squared minus 4ac is greater than or equal to 0. Okay, so when we went from this step here to this step here, for this to be true, something squared, this would have to be positive. Otherwise, it wouldn't exist. For those that do further maths, you'll meet complex numbers on your course, and you'll find that actually this does have solutions. But for those just doing A-level maths, as far as you're concerned, there are no solutions if b squared minus 4ac is negative. Okay? Let's put a little note there at the bottom. True if b squared minus 4ac is greater than or equal to 0. So we can now use the quadratic formula then to solve this quadratic equation that we had earlier. So we say x is equal to minus b, or b is minus 2, so minus minus 2 is positive 2, plus or minus the square root of b squared, which is 4, minus 4ac, so it's going to be minus 4 times a, which is 1, times minus 19, which is c, and that's all divided by 2a, which is 2. Well, that's going to be 2 divided by 2, plus or minus, that's going to be 76 plus 4 is 80, over 2. And using the simplifying surds, which I just done a video on, we end up with this as being equal to root 16 times root 5. But root 16 is root 4. Is 4. 4 divided by 2 is 2. So I get 1 plus or minus 2 root 5. And those are my two solutions. So 1 plus 2 root 5 and 1 minus 2 root 5. We can run that through this this quadratic equation to confirm that it does indeed equal 0. And finally, before I finish, one more example here. Another quadratic equation, x equals minus b, so minus 1, plus or minus the square root of b squared, that's 1 squared, minus 4ac, that's 4 times 1 times 3, all divided by 2a. We can see that this is minus 1 plus or minus the square root of minus 11 over 2. Well, this is one of those situations where b squared minus 4ac was negative, and we're trying to square root a negative number, so there are no real solutions. Okay, because you can't square root a negative number in the set of real numbers. So this equation has no solutions. There are no values of x, which make this true. All right, thanks for watching. Hope you found that useful. My next video will be analysing the discriminant in a little bit more detail. So that's b squared minus 4ac.